Hi, this is Herb Shapiro with the Dr. Vax channel, and today we're going to compare two critical pieces of software that we all use when creating 3D prints, because you don't start with a model that's properly defined for printing on your printer. You start with a 3D model from a 3D modeling program that is often saved as an STL file. An STL file is in fact a series of triangles that are overlapped in order to form a shape. Whether it's a simple shape like this that's used for testing overhangs, or a more sophisticated shape like this of a vase. Those 3D models, those STL files, are converted into G-code. G-code is a series of instructions to your 3D printer to print a layer at a time and build up until you create a 3D print. The software, as many of you already know, that you use for creating G-code from STL is called a slicer. There are many slicers, but I use two most of the time, and they both have evolved enormously over the last couple of years. That's the PrusaSlicer and the Cura Slicer. Today, we're going to compare them. But as exciting, we're going to go through those two slicers and look at about, 20 plus terms, parameters that you set in those slicers, and learn what they're called in each slicer. So if you're attempting, as an example, to set the extrusion dimensions, the flow rate on your slicer, it's called one thing in Cura and something else in Prusa. So stay tuned and let's learn something together. Now, our topic today is a very complex topic with a lot of material. So make sure you watch to the very end, because I'm going to show you how to get a copy of the slides I use in this video. And make sure you subscribe, you give me a thumbs up, and you recommend this video to others, because it'll really help support my efforts to produce content for the maker community using 3D printing, electronics, some woodworking, and even in the future, maybe some computer programming. Now, let's look at this screen together and talk a little bit about methodology. The goal of these tests are not to come up with a definitive scientific evaluation of these two slicers to determine which is best. I'll tell you right up front, neither is best. And so what we want to learn is when you should consider using one slicer versus the other, when you should consider that based on specific features, and when it's just a matter of personal preference. So in this methodology, the first thing I did, as you see on the screen here, is I created a print on a Prusa printer using a default profile from PrusaSlicer and from Cura, because both of them have profiles for the Prusa i3 MK3 that's behind me. Then I did something a little more complex. I took and I created a profile from scratch using default settings wherever possible for my Qidi XSmart. Now, Qidi doesn't make the XSmart anymore. It's about a year and a half old printer. I think they now call it the Maker. But it's a printer you don't see as often. It's a printer I really like. There are a lot of things about Qidi printers that are really just fantastic. But there is no off-the-shelf Cura profile, and there's no off-the-shelf Prusa profile. So I wanted to create a profile using the same parameters in both slicers, then take all the other defaults and see which did a better job printing. Along the way, we're going to learn a lot about these two slicers, and we're going to look at a whole series of various calibration prints I used in order to evaluate these printers. So let's get started with our evaluation. We're going to start here with the PrusaSlicer. This is version 2.2. I'm going to click on this icon to add a model. We're going to add our support test model, and you'll see that on the screen. When I'm using these products, I use an external 3-button mouse. So if I use the scroll wheel, I can zoom in and out. If I use the left mouse button, I can rotate. And if I use the right mouse button, I can move it around on the screen. Now, what's very nice about the PrusaSlicer is they have some standard configuration parameters right up here. And they do have a simple mode, an advanced mode, and an expert mode. I generally leave it in expert mode for both of my slicers because that lets me see all of the parameters. On the left-hand side, you have icons to move, to scale, to rotate. You have a very nice icon for placing the print flat on the print bed. This is a capability added to Cura recently. And you do have the ability to split a model horizontally, a very nice feature. So if I click on Slice here, we'll see the model slices quite quickly. I'm looking at the preview now. If I rotate this down a bit, and then I can go through the layers and look at the various layers. I can go back at any time to looking at the model. One of the things that's nicest about the PrusaSlicer is that if I take this top sort of arrow here and slide it down, I can go to a particular layer and then click on this plus key. And what I've defined now is I've divided my model into multiple colors. And at the point where I have that split, the PrusaSlicer will insert an M600 command into my output, a G-code command, that will, if your printer firmware supports it, not all printers do, it will automatically pause your printer and give you instructions on the front panel about how to change the filament. Now, how do you set settings? Well, in this particular slicer, there are 4 sort of tabs across the top. We were on the platter slide. You can go to the print settings, filament settings, and printer settings. Print settings are things unique to a single print. Filament settings are unique to a material, and printer settings are unique to your device. The Cura Slicer is arranged quite differently. I actually find it easier, but it's probably because I use it more. So I think you'll find that whichever slicer you use more, you'll be more comfortable with. So we're going to load the same model into this slicer. And we can use the scroll wheel once again to zoom in or out. We can use the right mouse button, in this case, to rotate. We can press on the scroll wheel and drag in order to position a model. If you click on this bar on the right-hand side, you can see all of your settings. Expand or retract a setting area. What's most important, though, is just as there's a basic, advanced, expert mode in Prusa, you have the same thing in Cura, and this messes a lot of people up. So if you go up to this hamburger menu here, you'll see you can select all, expert, advanced, or basic. I always select all so that I can see all the settings. So very often people go to Cura and they'll say, my version of Cura doesn't have that setting. It's just that they're in the wrong mode. So they're laid out quite different and the terminology is quite different. If we slice our model, we'll see one of the things I like the most about Cura that I think is really very useful. We're going to click on Preview here to see our model. I think they do a very good job on coloration on the model. We can scroll through our model in much the same way. There is no ability built in to scroll to a point and say, I'm going to change the filament. That is unique to Prusa. There is a way to do that with extensions, post-processing G-code, so you can add a filament change in at a particular layer. However, it's much less visual in Cura than it is in Prusa. Let's look at a couple prints, and then let's look at how the parameters are the same or different between the slicers. To begin with, I printed these ghosting tests on the Prusa printer using the PrusaSlicer and the Cura Slicer. To be very honest, they're really close. So now, let's look at the same experiment on the Quiddy printer. In this experiment, in fact, they are once again very, very close. It is hard to tell the difference. There's really no ghosting on either. Now, let's look at a little more interesting example. Very good example of tuning. I've printed, these are calibration prints that look for clearances. So these are labeled 0.5, 0.6, 0.5, 0.4, 3, 0.2. And you try to determine whether the pins will come out. The one printed on Cura, all the pins came out but one. On Prusa, only one came out. The rest bonded to the prints. And if you look at the bottom is not as clean. So extrusion flow rate, basically, is not as properly calibrated when using the PrusaSlicer defaults with the Quiddy printer as the Cura defaults with the Cura printer. Now, I do know if I print this print on the Prusa using the Prusa printer, all the pins come out. And I do know printing this using the Quiddy Slicer, which is a derivative of Cura on the Quiddy printer, I get the same result as this. So in both cases, once again, could I tune this for perfect prints? Absolutely. Now, the final thing I looked at was this model that I used to test overhangs. And because what I really wanted to see here was how hard is it to remove these supports. So let's go ahead and see if we can remove the supports on this model. I'm just using a needle nose pliers, and that support came off very easily. Let's try this one here. This one is on a little harder. Didn't come off completely cleanly there. This is printed with the Cura model. Let's try this one. Not, well, if I worked at it a little bit, if I grabbed it a little tighter, it came off pretty well. This one seems to be a problem on this one here. Let's try this one here. This one came off reasonably well. So not too terrible. I'll have to do a little bit of work to clean this up. This overhang here on this particular print is a little bit rough. Now let's look at the same thing on the print produced from the Prusa printer. And, well, this one's actually stuck on pretty good. Having trouble getting this support off. Let's try this one. This is also on pretty good. Let's try this one. Also on pretty good. Now this is consistent with the results I've generally found, and that is the supports produced by the PrusaSlicer seem to be a little tighter to the actual print and quite a bit harder to remove than the supports from the Cura Slicer. Once again, could I tune that? Absolutely. On the other hand, these overhangs that did not have supports are actually a bit cleaner on the print produced on the Quiddy with the PrusaSlicer, which means potentially flow rates and cooling might be better on this printer. Overall, these are both pretty good prints. So, what did we learn? Depends on the print, depends on the printer. Both produced pretty good prints on both printers. Interestingly enough, there were variations. So the Cura Slicer actually produced better fine type with default settings on the Prusa than the PrusaSlicer. But the PrusaSlicer produced better fine type on the Quiddy than the Cura Slicer. So it depends on your printer and your slicer. The bottom line, you need to tune your printer and your slicer and your filament to work together. 3D printing is as much art as engineering. Now, let's look at some of the terminology that's different between these two slicers and how to find where various settings are. I'm going to put up a series of complex tables on the screen. We're not going to go through every item, but I will tell you towards the end how to get these actual tables your own copy. On the main screen of Prusa and Cura, they have different information. On Prusa, they have information about infill, brim, and support, and you can actually change that information. In Cura, it's only displayable. One of the most powerful features of Cura is there's a search capability where you can type in the name of a parameter and it'll tell you how to find it. In addition, in both of these slicers, if you mouse over a parameter, you'll see a pop-up window with an explanation of that parameter. The parameters related to walls or perimeters, how thick these lines are set in the print settings section of Prusa. They're set in the shell section on Cura. When you're printing and you come to the end of a layer, you have to move up a little bit and start over again. That's going to leave a defect. That's called a Z-seam. You define that in print settings on Prusa, and once again, that's in the shell section of Cura. Cura has a very nice feature called ironing, which is promised for a future version of Prusa, but not available yet. And that says when you get to the very top layer, go over it one more time, but extruding little or no filament. In essence, use the hot nozzle to flatten out that surface. That's called ironing. Both of these slicers have the ability to minimize element feet. Well, if you see the very bottom, the first layer of a print, very often that first layer will spread a little bit. That's called an elephant foot. You define compensation for that under print settings in Prusa, shell settings, and it's called horizontal expansion in Cura. In addition, when you have holes in your print, you can ask the slicer to extrude a bit less so those holes don't close up. And that's under print settings in Prusa once again, and shell section, hole horizontal expansion in Cura. Now let's go to the next section. And you'll notice these are basically grouped together by the section names in Cura. Infill is under print settings in Prusa. It's a separate section in Cura. Material section is where you find many of the material related temperatures and flow. Those are under filament settings in Prusa. However, flow rate, 100%, 110%, 120%, how much to extrude is called extruder multiplier in Prusa, not flow rate. Speed is a separate section in Cura. It's under print settings. In Prusa, likewise, acceleration and jerk are under speed in Cura and print settings in Prusa. Now, the parameters called travel in Cura are in the print and printer sections of Prusa. So Z-hop and retraction are in the printer sections under the extruder definition. On most printers, you'll see extruder 1 if you have a single extruder, whereas retraction is listed under travel in Cura, so very different places. Combing is a whole different topic. Combing is where you're moving your print head over an area of the printer that's already printed, and you're not extruding filament. Well, normally you would retract before you do that, but you don't really care if you get stringing in an area that's already printed because it's going to be covered by the next layer. Unless you're on the top of the model where you'll see that stringing if you're on the top layer. So there are a series of parameters for combing and when to comb. Comb means don't retract because you're moving over a printed area, and when not to comb. The closest equivalent to that in Prusa is the print setting to avoid crossing perimeters and whether to wipe while retracting. Now, wipe while retracting says don't retract in place and then move. Start retracting as you move, as you travel. But that could cause stringing, but it will eliminate blobs at the beginning area where you're doing the retracting. So combing and the avoid crossing perimeters and wipe while retracting parameters are both designed to help with stringing. Cooling is under the filament section in Prusa. It's a separate section in Cura. And a very important parameter is minimum layer time. That says if you're done with the layer and you haven't spent this amount of time, pause. Why? So the filament on that layer can harden sufficiently before you put the next layer on it. However, if you set that too long, your prints are going to take a really long time. And so sometimes, in particular when printing in vase mode, you can reduce that because these are very thin walls. They're only 1 nozzle width wide, and therefore you don't need that extra cooling time. Supports are under print settings in Prusa. They're a separate section in Cura. And skirt brim and raft are in 2 different places in Prusa, and they're under build plate adhesion under Cura. The next parameter I want to talk about is maximum resolution. It's under print settings in Prusa. It's under mesh fixes in Cura. When you're printing, in essence, you've taken the triangles that are created in your STL file and defined them into layers. And so in essence, a print is not a series of dots. It's really a series of segments. The smallest segment that you'll attempt to print is the resolution. If you have that too small, then you'll get more bumps and artifacts in your print. You see that very often in printing of vases. So if you're getting bumps when printing vases, try to make the resolution, the maximum resolution, bigger so that you have less segments, less places for those bumps to form. And you can do that in both Prusa and in Cura. Vase mode, very interesting. It's under print settings in Prusa. It's under the special mode section in Cura. Now in Cura, when you select spiralize outer contour, it automatically is going to pop up a box saying it's going to change some other parameters for you. Prusa will ask you if you want to change those other parameters. They'll give you the option, or you can change them manually. And coasting is under the experimental section in Cura. That's where when you get towards the end of a line that you're extruding, stop pushing out more filament so you sort of eliminate blobbing. That's an experimental feature in Cura. It's not currently available in Prusa. So folks, a lot of material today. How do you get a copy of this material? You go to forum.drvax.com and there will be a special section for registered users, a special section of the forum just for registered users. I think it's the second item, the second major topic. You'll only see it if you're registered. So you have to register for the forum. The forum is completely free. It's a place where hundreds of my users exchange comments and ideas and actually print images, because you can upload images to forum.drvax.com and talk about what you've learned from the Dr. Vax videos and just help each other out. So if you go there and you registered, under the registered users only topic, you will see a link to this presentation. Thanks so much for watching. If you liked it, give me a thumbs up, subscribe to the channel, recommend it to your friends, and let's continue to learn things together.